Hello and welcome to my video lesson. In this video lesson, I gonna to share with you the atomic radius chains. And the main content for this lesson is about define the atomic radius. And the second one is factors that affect the atomic size. And the third is the unit for measurements of the atomic radius. And the fourth is the atomic radius chains in periods. And the last one is the atomic radius chains in group. Now let's begin with atomic radius. The atomic radius is a measure of the size of an atom, and the size of an atom is defined by the edge of its orbital. Look at the figure here. You can see this is an atom, and this is the nucleus, and this is the electronic cells. And from the center of the nucleus to the outside or the farthest the cell, this is radius or atomic radius. However, it is really difficult to calculate the radius of individual atom because the atom is very small, and the electron clouds surrounding the atom do not have a particular shape boundary, so the determinations of the size of a radius atom cannot be precise. One practical approach of finding the radius atomic of an atom is measure the distance between two identical atoms. This is two identical atoms, and here is the distance between two nucleus of two atoms. So the atomic radius is defined as one half the distance between the nuclei of two identical atoms that are bonded together. As you know that the size of an atom is extremely small, so the units used to measure atomic radius is the most common is angstroms. 1 angstrom equivalent to 10 to the power of minus 10 meters. And they also use nanometers units to measure atomic radius, and 1 nanometer equivalent to 10 to the power of minus 9 meters. What influences the atomic size of an atom? There are three main factors that affect the atomic size of an atom. The first one is the number of cells. It means the number of electron cells. Atomic size increase with increase in number of electric cells. Therefore, atomic radius is directly proportional to the number of electric cells. Or we can say the more electron cells, the bigger in the size of an atom. The second one is the nuclear charge. This is the main factor that affects the atomic size of an atom. As the nuclear charge increases, atomic size decreases due to the increase in attractive force. Thus, atomic size is inversely proportional to the nuclear charge. Or you just think when the nuclear charge increases, the attraction force between the electrons and the nucleus increases, so the atomic radius decrease. The third factor that's skinning effect, and it will happen in an atom having more electrons or having more electron cells. The inner orbits decrease the attraction between the electrons in the outer orbits and the nucleus. Thus, they act as skins between electrons of outer orbits and nucleus. As the skinning effects increase, atomic size also increase. Therefore, atomic radius is directly proportional to the skin effect. Now let's move on atomic radius chains. Look at the green. You can see this is all elements in group A, from group 1A to group 8A. Did you remember all elements in each group? I give you 10 seconds to remember and write down the name of each element of each group. Okay, time's up. Let's review a little bit about the elements in groups A. The first one by the color. The red color is alkaline metals. The orange is alkaline earth metals. The green is basic metals. The blue is semi-metals. The dark blue is non-metals. The purple here is halogen groups, and the brown here is noble gas. Okay, group 1A. Hydrogen, lithium, sodium and potassium, rubidium and cesium. You need to remember the most common elements in each group. So in group A we remember hydrogen, lithium, sodium and potassium. In group 2A we learn barium, magnesium, calcium and barium. In group 3A, we should remember aluminium. In group 4A, we should remember carbon and silicon. In group 5A, we just remember nitrogen and phosphorus. In group 6A, we remember oxygen, sulfur. In group halogen, group 7A, we remember fluorine, chlorine, bromine, and iodine. And noble gas elements we just know don't study. Okay, let's come back to atomic radius chains. And you can see on the table here, each circle is represented for the size of each atom. And the biggest one is francium, and smallest atom inside is helium. In each period, from the left to the right, the atomic radius of atom is generally decreased. Atomic radius decrease, and from the top to the bottom in a group, atomic radius of atoms is generally increase. Atomic radius increase. Okay, now let's give a conclusion about atomic radius trends. The atomic radius of atoms generally decrease from the left to the right across a period. Here, atomic radius decrease across a period. Atomic radius of atoms generally increase from the top to the bottom within a group. From the top to the bottom, atomic radius increase. Okay, what did we learn today? Today we learned about atomic radius and atomic radius strengths. Atomic radius is determined as the half distance between the nuclei of the two identical atoms bonded together. Atomic size affected by the number of cells, a nuclear charge, and skin effect. Atomic radius strengths. There are two strengths in atomic radius. Atomic radius of atom generally decrease from the left to the right across a period, and atomic radius of atoms generally increase from the top to the bottom within a group. Okay, now the time for revisions. Can you answer these 5 questions? Question 1. Define atomic radius. Question 2. What are the units for measurement of atomic radius? Question 3. How the atomic radius changes across a period? Question 4. How the atomic radius changes from the top to the bottom within a group? Question 5. Explain why the atomic radius of hydrogen is so much smaller than that of potassium. Okay, this is the end of the lesson today. Thank you and see you next time.